Hello again. The new thing we've moved on to now is called gene mapping, and it has to do with figuring out on a chromosome or on a strand of DNA where are all the genes and in what order do they appear. And we can figure out how close together genes are by figuring out how often they're separated by a crossover cut. Just to demonstrate this really quickly. If you have a chromosome and there's a gene over here, A, and there's a gene over here, B. And if you make a random cut through that chromosome, like happens during crossover, most of the time, I'm trying to throw these in random locations, nearly all of those cuts are going to separate A and B. They'll end up on opposite sides of the cut. In this case, only one of them didn't. And what that means when they're usually separated is that they're a great distance apart on the chromosome. We can actually measure how far apart they are as a percentage and turn that into a distance, like in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. In this case, 8 out of 9 of the cuts separated those two chromosomes. That translates to an 88.8% crossover percentage, we call it, meaning the crossover cuts separated those two genes 88.8% of the time. And from that, we get what we say their map distance is, let's round it, 89%. So when we're drawing the chromosome, we'll say we have to draw it with these two genes, A and B, 89 units away from each other. If you have another two genes like A and C really close together, you'd find most of the time when you throw a random cut on this chromosome, it does not land between A and C. That means they aren't separated very often. Their distance might be like 4%, and that means their map distance is considered to be 4. They're only separated 4% of the time, and that translates to a small distance on this map. So we don't get into a lot of detail about the cutting, but what we do very often is we'll give you a list of percentages like this, and we'll say draw a map of this chromosome. So what we're saying is on this chromosome, these two genes are 2.5 units apart. These two genes are 3 units apart. These are 5.5 units apart, and so on down the line. And we have to come up with an order and an arrangement that makes sense and that fit all these numbers. It's actually easier than it sounds. The first step, we highly recommend you find the two genes that are the furthest apart from each other. Here they helpfully put them in order for us. Find the two that are at the greatest distance and put those on the two ends of the chromosome. So here, genes C and D are 11 units apart. I've already marked this thing so it has 11 big lines on it. So from the far left to the far right is 11 of the steps. The gray ones here are half units. So we can say we've got gene C on one end, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steps to the right is gene D. So good, one down. Now, from there, if we tried to do this combination, this one is talking about A and B, and I don't have either of those genes down on the list yet. So you don't want to try a combination where you don't know where either of the genes lands. That's going to be painful. So for now, let's skip over this one and try the next one. This says genes A and C are 3 units apart. Well, we know where gene C is, so gene A must be 1, 2, 3 units over. It's right here. Got that taken care of. Now that we know that, can we try A and B? Now, something else is going to happen. We'll see in a second. This says genes A and B are 2.5 units apart, but here's a problem. Starting from gene A, we could go 1, 2.5. We could put B there. We'll put B question mark. Or we could go 1, 2.5, and we could put B here. If you want to pencil that in with the question marks, that's okay. But generally, when we get one like this and we're not sure which direction to go, you can just skip it and come back to it later. I'll leave these on for now just to remind us, but I'm going to say let's not do the A and B right this second. Let's try for another one. B and C are 5.5 units apart. This is helpful. C is on the extreme end. So if we're going from C to B, there's only one direction we can go, and it's to the right. If we do 5.5 units, 1, 2, 3, 4, 5.5. Ah, okay. Now we know where B is. It was this one. That's the correct location for gene B. And now that we have that, I don't need these question marky things anymore. We found where B is. Okay, so B and C is done. A and B are 2.5 units apart. 1, 2.5. Yep, looks good. B and D are 5.5 units apart. 1/2, 1.5, 2.5, 3.5, 4.5, 5.5. Good, that works. A and D are 8 units apart. 1, 2, 3, 4, 5, 6, 7. Yep, that checks out also. So we've met every requirement on the list, and it wasn't too bad, I hope. Just remember, it's really helpful to start with the two that are the farthest apart and use them as your bookends, and then everything else is going to fit in between them. And if you ever have one where you don't know if you should be going left or right, skip it and come back to it. There's generally a way to get through these without having to do any guesswork. We usually give you plenty of information. It's just a matter of don't place a letter unless you're sure it's in the right spot.